Right, we have the scalene triangle that is not drawn to scale. Try to draw a little bit better on the board here. We don't know that side B. We're given an obtuse angle of 145 degrees, given 6 inches and 8 inches. So we are looking for side length B, angle A, and angle C for this. So where can we begin to solve for the now 3 unknowns that we have in this problem? Right, if we use law of cosines to find B, just think about before we write it, it means the other 2 sides we know, and the included angle of the other 2 sides we know as well. So by starting with law of cosines to find B, we're only going to have 1 unknown if we start that way. So that's, I would say by hand, a better place to start, because we'll only have that 1 unknown. So using law of cosines here, we have the 6 and the 8 minus 2 times 6 times 8 times that included angle 145, times the cosine of that included angle. So setting up this way, we start with 1 equation for the 1 unknown B. Go through this, I can take the square root of both sides and find that the value of B, that length is 13.4 inches. Now I would say at this point, if we want to find angle C, law of cosines would be good to use as our second step, because now we know the value of B. So let's just say we want to find C next, or angle C next. So we can set it up. The only way that angle C is going to be in our law of cosines is if 6 is our left-hand side, the way that it's set up here. So we know that 6 squared is A squared plus B, which we just found, minus 2 times 8 times the 13.4 times the cosine of C. Now, as the second step, we have only 1 unknown, the value of C here. And if we do solve this for C, taking the arc cosine, we get that C is 14.9 degrees. How else could we find C, though, if we didn't use law of cosines in this format? Right, we could use law of sines as well. In this case, I would be fine using law of sines, even though we're looking for an angle measure, because we were given the obtuse angle of 145. So A and C must be acute, since it's a triangle. So law of sines I would be okay to use here. So I could say that the sine of C over 6 is, say, the sine of, the only other angle I know is the 145, over the opposite side, B of 13.4. And if I go through those steps, I should find at least the 3 digits. They should be the same, 14.9 degrees, whether I use law of sines or law of cosines. Again, just keep in mind with using law of sines when you're using arc sine, if I just started here and I didn't have that obtuse angle, I want to check at the end to make sure that my ordering agrees, and we'll do that for this problem too. All right, so we found the value of C. We found little b, so how can we find A? Yeah.
Well, we can just subtract from 180.
Right, we know that any triangles, internal angles equal 180. So 180 minus 145 that we're given, minus C that we just found was 14.9, is going to be the value of A. Or we could use law of sines, law of cosines. This is much quicker though, assuming we did these steps right. We get that angle A, for this to be a triangle, has to be 20.1. Right, so we have the 2 angles we didn't know before. We have that last side. Now, for this exercise, I will check. Again, the largest angle has to be opposite the largest side, and then medium, and then small. So starting with our largest angle is 145, B is 13.4, that's larger than 6, larger than 8. Our next angle in size is 20.1, that's across from the 8 inches, which is bigger than the 6. The smallest angle, C, 14.9, is opposite the smallest side of 6 inches, so this is a feasible triangle to make. So especially you want to do that check if you've used law of sines to find an angle measure, just to make sure you didn't accidentally find the supplement to the angle because it turned out to be an obtuse angle.